All right, so we kind of ended mid-thought in the last video, so let me quickly finish up this example, and then we'll start talking about estimating sample size. So we've got these values. We found them in 3 different ways, by hand, using Excel, and using Desmos. The commands are there for you in the previous video if you need them. And then we just stick those numbers into our equation for the margin of error, and I get about 3 1/3 years. It's not 3 1/3 exactly, but that's close enough for government work here. So that's my margin of error. I need to build my confidence interval using this margin of error and my sample mean. So I'm going to add and subtract to get my upper and lower bounds respectively. And I get the mean completion time for a 4-year degree is somewhere between 2.3 years and 9 years, because I've added 3.33 years to my mean to get 9 years, and I subtracted 3.3 years to get 2.3. That is what we got, right? That's our value for 95% confidence for the values we've got for 20 students. That said, this is not great, right? This is a huge interval here. This is huge. It takes somewhere between 2 years and 9 years to get a 4-year degree. Okay, that's not terribly insightful. So let me ask you this. If I want a much tighter interval, how many students should I be surveying? Or specifically, how many students should we survey in order to be confident about our population mean? And the question that we've been asking this whole chapter, right, previous series and also this series, how confident do you want to be? So here's how we're going to estimate our sample size for a sample that we've not actually yet taken. Right, we're going to do exactly what we did in the last chapter, where we rewrote the margin of error equation, and that gets us n is equal to critical value times sigma over margin, and that number is squared. So I need to make this estimate my critical value, which is of course based on my confidence level. I need the population standard deviation, and I need my margin of error. And if you're really on your toes, you might be saying, well, why don't we use the t stuff? Why don't we use the other equation? Well, we can't. I'm sorry, we just can't use this one. That's because s and the t value depends on your sample size, which we are trying to find. So it's recursive. We can't actually solve for it using this equation. We have to use this one. So we have to, maybe that makes life a little easier, right? We're getting back to the z stuff that we like z-scores. But anyway, here's how we're going to do it. Right, we need 3 things to find n. We need the critical value, we need sigma, and we need e. So first of all, let's go ahead and knock 2 of those out right away. I'm sorry, yeah, we'll knock 2 out right away. We're going to decide on the confidence level and the error margin. Just straight up decide those things. Once you've got that confidence level, then you can get the critical value. And then also we'll take a stab at the population standard deviation. So first of all, confidence level. Rule of thumb, you don't have a better idea, 95%. Just is what it is. If you have a risk of losing money or a risk of loss of life, then you want a higher confidence level. If you're wanting to shoot from the hip and just get a quick and tight estimate, then you will go for a lower confidence level. But if you can't think of a reason not to, 95%. Also, I want to be within a year. So I am choosing E to be 0.5, which is half a year. Half a year above, half a year below, 1 year is my total interval. Next up, I'm going to look up the critical value. So let's see here. I've got the t-table here. It's good for z values as well. Right, 95 confidence level, 1.96. There it is. That's our critical value. And then finally, taking a stab at the standard deviation. What do you think the standard deviation would be? And if you have no idea whatsoever, which I didn't when I was thinking through this, the way you can come up with a quick and dirty estimate for standard deviation is just think about the range of your data divided by 4. So, right, the 4-year degree obviously takes 4 years to take. And then at the longest, we'll say it takes, 12 years. So that's an 8-year range, divided by 4, standard deviation of 2. And that's how we do that. So we'll wrap this up in the next video. See you then.